In this video, I'm going to discuss our next lab exercise where we're going to be studying lenses. And this lab is going to be done virtually. So what we're going to do is we're going to be using one of the simulations by the PHET group at the University of Colorado at Boulder. So let's get started. So first thing to do is to go in your web browser and type in PHET, PHET, .colorado.edu. All right. So that'll bring you to their web page. And then we want to use one of their physics simulations. So just go to the menu and select simulations and then select physics. From there, we're going to be using a simulation in the light and radiation. And so if we scroll down, there's a simulation called geometric optics. So we'll select that one. Okay, so now this simulation uses Flash. So if you don't have Flash downloaded and installed, you'll need to do that. So if I go ahead and start the simulation. Okay, so in this simulation, there is a converging lens right here in the center. There is an object which is desperately asking me to move it around. And what you'll notice is that when you move around this object, that it also will correspondingly move the image over here on the right-hand side. So there's a lot of different features in this to kind of become aware of before you actually do any of your measurements. So first off, you'll notice these X's on the axis here. So those are the focal points. So the distance between the center of the lens and that X is the focal length. The other thing you'll notice is that that it's showing three rays for ray tracing that originate from the object, make their way through the lens, and then converge on the other side to form the image. So in this case, I'm using the marginal rays. So you'll see that it's selected up here on the top left, where it essentially takes one ray, which goes straight through the middle without refracting, and then it'll take another ray, which intersects the top of the lens and refracts, another ray which goes through the bottom of the lens and refracts. And so we're showing these three rays, which will then focus at that point. You could go up here and select the button for many rays, which is kind of a nice illustration to show that, you know, there are a lot of different light rays emanating from the object, and we're only really focusing on the ones that go through the lens. Okay, so that's kind of a nice illustration. We're not going to be using that in the measurement. There also, which I think might be more helpful to kind of get an idea of how the light from the object is focusing to a point to form the image, and that is if you select principal rays. There, the three rays, you still have the one ray which goes through the center of the lens but doesn't refract. And then you have another ray which leaves parallel, and when it bends through the lens, then it is going to go through the focal point on the other side. And then if we take the third ray, which goes through the focal point on the same side as the object, then it is going to be bent and come out parallel on the other side. So this is probably the ray tracing that you've maybe seen during lecture. So this one is actually quite helpful in kind of showing how the images form based on the rays of light that are leaving the object. There's also another button here for second point. So we could pick a second point, and I can actually move that, say, let me move it to the other end of our pencil. And then we can move this object around, and you can kind of see that you're getting the same set of principal rays from the second point, and those rays are coming over here and focusing to form the image at the top, which is the eraser. And whereas the rays that are in white are ones that are forming the image of the pencil tip. Okay, so again, those are kind of a very nice illustration. I'll just take that away so it's not distracting too much. And then the other part is if you look over here on the right, you can show I could change this around and make this a screen. So now it's a lamp, which is now emitting light rays and forming on a screen. And you can move the screen to where you focus to a point, or you can move it forward and show that you're getting a more diffuse image, one that's not really focused, but in this case would be very fuzzy. So that's kind of a nice illustration. So I'll get rid of that. And instead, we're going to be working with objects. You can change the object. I could make it a star, a smiley face, an arrow. For my demonstration, I'm just going to stick with the pencil. So the simulation should be what we would have observed if we had done this experiment in the lab, where you have an object, say this upside down pencil, which the light rays through this converging lens would then form an upright or vertical image. Okay, so there's a few things that we can do to change the lens. So you can change the refractive index. So instead of having an index refraction of 1.53, I could make it smaller. And so you can kind of see the effect of the light rays not bending as much. Or we can make it such that the index refraction is much larger. Now those light rays are really bending as they go through the glass, and the image now is much closer. So I'm going to put it back to where it was, around 1.5. I can also change the curvature of the lens, where now changing the curvature changes the focal length. So you can see those X's are now changing. If I make the curvature really kind of, if I reduce the curvature, the focal lengths get smaller. If I increase the curvature, the focal lengths get bigger. So I'll go back and leave this at something, right in the middle somewhere. Last is we could change the diameter of the lens, and you can see that that makes the lens smaller. And so what you'll notice is that as I make it smaller, it doesn't change necessarily the position or the way that the image looks. Instead, what it is you're cutting out more light that can be used to focus the image. So the image becomes much dimmer. If I go ahead and put those, the many rays out there, you can see we're not catching as much light to the lens, so we're not getting a nice, sharp, bright image. Instead, it's much dimmer. So for the exercises that you do, I would recommend just to kind of make that lens as big as possible, go to the other end of the scale, just so you have a nice, bright image. Okay, so this is all very qualitative kind of demonstration of how the converging lens works. For the measurement that you're going to be making, what you're going to need to do is now activate the ruler. And I'm going to get rid of the rays. We don't need the rays anymore. Those are kind of just give the principle of focusing light. And instead, for the measurement, what you're going to do is, position the object. And then what you can do is you can measure the, let's say the object distance. So the distance from the pencil to the center of the lens. You can then measure the image distance. So now the distance from the center of the lens over here to wherever the object is. And then you can also measure the focal length. So you can measure from the center of the lens to wherever this X is. And what you're going to be doing in your lab is to change the object distance, see what the corresponding change in the image distance is, take, let's say, 5 data points, and then make a plot, which will be described in the lab write-up. Make a plot of the 1 over the object distance versus 1 over the image distance, and then from there, extract from your plot the focal length. And then you can compare that to the actual focal length that you would measure with a ruler. And so in the end, what we're doing is really kind of testing this lens equation, which involves the image distance, the object distance, and the focal length. And what I would recommend, and again, this will be in the write-up, is that you choose distances for the object are greater than the focal length, and then is also less than the focal length. So I want you to take measurements with the object at a distance that is less than the focal length. And what you'll see is that our image has pretty much gone off the screen. We don't see it anymore. So what you can do is you can click this one button over here for virtual image. And when you do, you now see that the image is virtual and it's on the same side of the lens as the object. And so when you're taking your data, I want you to take some points that are, say, on the have a object distance greater than the focal length, and some that are also less than the focal length. So you can get both real and virtual images. So good luck.